Okay, so we are moving on with our triangle unit. So before we discussed what type of triangles, and now we're going to talk about congruent triangles. So our question is going to be, how can you prove triangles are congruent? You're going to use, identify and use corresponding parts. So remember corresponding parts that go together. And these are the different things we're going to look at. We're going to look at side, 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 angle, side, angle, 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 side, and side, angle, side, and hypotenuse, leg. So it's a lot of letters. All right, so here we go. When given congruent polygons, and since a triangle is a polygon, this does apply, corresponding blank are congruent and corresponding blank are congruent. So we're going to do, maybe, okay, we're going to do corresponding angles. So corresponding angles are congruent. Oh Lord, why is this thing not writing? So corresponding angles, sorry, don't know what's going on here. This thing is a mind of its own apparently. So corresponding angles, I don't know what that is, and corresponding sides. So the sides and the angles are going to be congruent. So what we're going to do is looking at these two pictures, they give me ABCD is congruent to EFGH. So I always do 1, 2, 3, 4, 1, 2, 3, 4. And that way I don't have to look for this angle and this angle and so on and so on. I just go straight to those numbers. So 1, 2, 3, 4, because it's a lot easier to match 1, 1, 2, 2, 3, 3, so on, so on. E is 1, F is 2, 3, 4. So now when I'm listing what's going to be congruent, then I can list my sides. So AB is congruent. So AB is 1, 2, and it's congruent to EF. So A 1, 2 is congruent to 1, 2. 2, 3, BC is congruent to 2, 3, FG. 3, 4, which would be CD. CD is congruent to, oops, that should be 1, that should be 2, that should be 3. 1, 2, 3. So CD is congruent to GH. And 1, 2, 3, 4 is congruent to 1, 2, 3, 4. So AD is congruent to EH. And then when you're matching up your angles, 1 goes with 1, 2 goes with 2, and so on. So angle A goes with angle E. Angle B goes with angle F. Angle C goes with angle G. And angle D goes with angle H. And if you'll notice, the first one goes with the first one, the last one goes with the last one, and so on and so on. All right, so if we look now, it says write another congruent statement for the polygons in number 1. So another one could be, I can rearrange these letters. I could go 3, 4, AB. So I could say CDAB is congruent to GHEF. You can rearrange the letters as long as you go in order. So now on this one, let's find the value of X and Y. So the value of X and Y. Well, since I've got 1, 2, 3, 1, 2, 3. So X, Y, Z goes with R, S, T. So 1, 2 goes with 1, 2, and I don't have any information about 1, 2, and 1, 2. I know 1, 3. So 1, 3 goes with 1, 3, and I don't have any information about that, other than I know this one is also 15. But I see that this is equal to this, so this one's also 15, and this one is also 15. So that means that 3y plus 9 is equal to 15. So subtract 9. 3y equals 6. Divide by 3. Y is 2. And since my angles have to be congruent, since this angle is 30, I know this one's also 30 because that's your, remember if you have two equal sides, you have two equal angles. And if these two sides are equal, then these two are also equal. So that means that 2x minus 20 is equal to 30. So add 20 to both sides. I get that 2x is 50. Divide by 2. X is 25. And that's pretty much all there is to it. Not a whole lot. All right. Now, these are our congruence theorems. So there are 5. A right triangle uses all 5 of them, but all your other triangles will only use these 4. So the right triangle has more options. So side, side, side. That means all 3 sides are equal to all 3 sides. So for example, in this one, I have an angle, and I have an angle, and I have a side, and an angle, and an angle, and a side. So since I have 2 angles that are consecutive and then a side, these 2 would be considered angle, angle, side. So angle, angle, side. So A is angle, angle, side. If I look at B, I've got a side, and a side, a side, a side, and a side. So these 2 would be side, 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 which would be number 4. And in the next one, I've got a side, an angle, and a side, an angle, and a side. So if you'll notice, the angle is between my 2 sides. So when I connect the sides, the angle that they gave me is touching both. So this is side, angle, side. So it's kind of the order of the picture. Side, angle, side. So that would be C. This one, I have 2 angles and the side that connects the 2 angles. And here, an angle, and the side that touches both. So this would be considered angle, side, angle. So angle, side, angle would be D. And then this one is the right triangle. So you have your right angle. That has to be there. This is the hypotenuse, and I see that the hypotenuse are congruent on both. This is the leg of the right triangle, and they're congruent. So this is known as hypotenuse leg. So hypotenuse leg is E. We cannot prove triangles are congruent by angle, angle, angle. This one does not work. Or side, side angle. Okay? So you cannot use these 2 at all. And we're going to get lots of practice, I promise, because I know this is a lot of information. So now we're going to use those properties, and we're going to see if we can prove these pictures by what we have. So I see I have QPT and RST. So this side is equal to this side, so there's 2 sides for each. This side equals this side, so there's 2 more sides. And this side equals this side, so there's 2 more sides. So this triangle is congruent to this one by side, side, side. That one's the easiest one. Here I have a right triangle, and I see that my hypotenuse is equal to my hypotenuse. I see I have a leg equal to a leg, so this is hypotenuse leg. Here I have these 2 triangles. I have this angle equals this one, this angle equals this one, and this side is congruent to this side. So in this one triangle, I have angle, side, angle, and in this triangle, I have angle, side, angle. So these 2 are angle, side, angle. Okay, over here I have a right triangle, but they didn't tell me anything about the hypotenuse, so I'm not going to worry about hypotenuse leg. So you don't know about the hypotenuse. You don't know about the hypotenuse. So this is a side, and it's congruent to this side. This side is congruent to this side, and this angle is congruent to this angle. So do you see how the angle is connecting my sides? So this would be side angle side, and the same thing over here, side angle side. So these two are congruent by side angle side. So if you don't know about the hypotenuse, do not worry about hypotenuse leg. All right, on this one, this side is congruent to this side. This angle is congruent to this angle, and this angle is congruent to this angle. So I have angle, angle, random side, angle, angle, random side. So these two are congruent by angle, oops, that's the wrong spot. These two are congruent by angle, angle, side. Now I need to figure out, well, what triangle? So ABC, so 1, 2, 3. So 1, 2, 3. So it's triangle DFE. So triangle DFE. Order is extremely important. Order matters. Order matters. All right, so here, it's a right triangle, but again, I don't know anything about the hypotenuse, so don't worry about hypotenuse leg. This right angle goes with this right angle. This side goes with this side, and this angle goes with this angle. So these two are congruent by angle, side, angle. So 1, 2, 3, 1, 2, 3. So X, Z, Y. Order matters. All right, so let's look at some hidden information. So in our hidden information, the reflexive property remembers when something is equal to itself. So anytime you have two triangles that are connected, they're always going to share a side. And if they share a side, it's all automatically equal for both. So for example, this side goes with this side goes with this side, and this side is equal to itself in the other triangle. So these two triangles are congruent by side, side, side because of the reflexive property. Vertical angles, you know that vertical angles are always going to be congruent. That's a given. That's something they expect you to know. So this angle goes with this angle. This side goes with this side. And the angle here goes with the angle here. So I would have two angles and a random side. So these two triangles are congruent by angle, angle, side. And then there's always the alternate interior angle theorem. Remember, if this side is parallel to this side and this is a transversal, then this angle is congruent to this one by alternate interior angles. Now I know that this side is this side. And remember, being parallel has nothing to do with being congruent as far as the sides go. This side's equal to itself because it's shared by both triangles. And then I have this angle equal to this angle. Okay, so make sure that you look for alternate interior angles. Always look for alternate interior angles. All right, so let's look. We're going to label our sides. So this side goes with this side. This side goes with this side. They share this side. So this side goes with this side. So these two triangles are congruent by side, side, side. And I used my hidden information. Here, these two triangles are twisted. So I know that this angle is equal to this one because they're vertical. So this angle goes with this angle. This side goes with this side. This angle goes with this angle. So these two triangles, I have two angles and a random side. So two angles and a random side. So triangle WXY is congruent to AZY. So AZY. Okay, here, this is equal to itself. This angle is equal to this angle by alternate interior angles. So I've got a side goes with a side. This side is equal to itself. And this angle is equal to this one. So that gives me side, angle, side. So side, angle, side. So ZAY, so 1, 2, 3 goes with, so if it's ZA, then I've got to go BYA. So these two are my 3's because those are the two that are equal. So corresponding parts have to go together. So this is going to be BYA. All right, last part says state what additional information is required in order to know that the triangles are congruent if I have to use the given reason. They want me to use angle, side, angle. Well, I've gotten 2 angles from both, and the side has to be the side that's in between the 2 angles. So this side needs to be congruent to this side. So I would say I need DE to be congruent to JK. I need DE to be congruent to JK. So the S is in the middle, so the side has to be in the middle. Now they want me to use side, angle, side. Well, I know this angle is congruent to this angle because it's vertical. So this side goes with this side. This angle goes with this angle. Since the angle is in the middle, then I need this side and this side to be equal to each other so that I can have side, angle, side. So I need WV to be congruent to MV. So if I know that these 2 sides are congruent, I can use side, angle, side. And then over here, that's my answer, so it's easy to find. All right, and we will cover more of this whenever I get back, and I will see y'all then.